Hello, it's another Feed Scroll Generator tutorial for Autodesk Inventor. This time we're looking at something nice and complex. What we have here is two shaft parts assembled in an assembly, and we're actually splitting the bottles that go from left to right. Some are going up and some are going down, or left and right, as they move along the shaft. Let's take a look at this if we drive the constraint. And I might slow this down a little bit so we can actually see what's going on. So here we are, you see the shafts rotating. One bottle's going left, the next bottle is going right as they move along the shaft. We can't actually see the bottles, but we can see the space that this elliptical bottle, in this case, would occupy. So this is the kind of geometry that we can create with the app, but we don't do it all in one go. We do it by creating multiple shafts, and as we saw in tutorial number 3, we merge the shafts together and we combine them to create more complex combination shafts, if you will. So because the process of creating a splitter shaft like this is actually quite can be quite complex to understand, we've got a PowerPoint that we're going to look at that outlines the process before we actually jump in and do it. So let's just stop this recording now and cancel out of that. So hopefully you can see this is the end goal that we're aiming towards. Let's head over to our PowerPoint and look at the process of how we actually get there. Okay, so the first step is to always create a plan. You know, I've got an AutoCAD drawing here which demonstrates the end goal I'm after. So, you know, the start pitch, the end pitch, the end diameter here, the end diameter of the outer bottles, the bottle profile, all that kind of thing. And you can use this as reference and check that it makes sense before you actually start drawing the shafts. And once we've got that, we generally start with preview builds because they're faster. So you'll see initially a lot of these builds are blocky geometry, which we later convert to smooth geometry as we did in some of the other tutorials. So we create a preview build of the shaft where the bottles move outwards first. I'm assuming here that some of the bottles are going to move out and some of them are going to move in, but of course some of them could stay the same and some could move out. It's up to you how you want to split them, but here we're going out and in. Okay, and then we consider setting the solid body color to something else so that it helps with the visibility later on when we're merging the two. And then we create a preview build of the in shaft where the bottles move in towards the shaft. You can see the difference there. And so we've then got two preview build shafts. And then the third step is we derive one part into the other, as we did in the previous tutorial where we grouped the bottles. And then once we've got the two solid bodies on top of each other, we then have to use the Move Body tool to rotate the derived shaft by 180 degrees so that, well, in that case it would mean that the bottles are perfectly evenly spaced. We don't have to make it 180 degrees, of course. And then we combine the two shafts using the Boolean intersect as we've done in previous tutorials, and that will give us a result something like this where we've got a combination. We've got the bottles moving out and in, and this is where we realize whether we've got enough pitch between the bottles, and it's also helpful to see the color of the different shafts in the single shaft here created. Then we can sculpt away the outside of the shaft to get rid of some of the extra protrusions here, because the app won't do that automatically for us. It lets you do that as a separate operation if you want. And then it's a good time generally to check in an assembly how these two, how the left-hand side and right-hand side shaft might assemble together and how much extra clearance we need, because of course they've got to mesh with each other. Now in this case, we've got two instances of the same shaft assembled together in an assembly. That's because the bottle profile is symmetrical on the top side and the bottom side here, or the left and right side, and also the bottle is not rotating. So if either of those scenarios was not true, then we would have to separately model the left-hand side and right-hand side shaft here. And you saw in tutorial number 3, you saw that we would have needed a different shaft for the opposite side because the bottles were rotating. So that makes it more complicated, but it's still perfectly possible to do. So we can see here that we do definitely need some more clearance to get these two shafts to mesh together properly. So step number 8, if we need extra clearance, then here's where it can get slightly conceptually confusing if you haven't done it before. But we actually have to model an extra shaft which is going to sculpt out the extra clearance for us. It's going to sort of scoop out an extra chunk of the shaft to provide the clearance for the meshing shaft to the other side, if you see what I'm saying. So we need to model a separate, we're going to call it a clearance shaft. Model a separate out clearance shaft where the bottles are moving out. And then step number 9, we have to return to the original in shaft, take a copy of it, and model a new clearance shaft for the in shaft. So this is going to take another chunk out of that shaft as the bottles are moving inwards. And then we have to Boolean intersect the original in shaft with the new in clearance shaft. So this plus this, you see the bottles move in the same direction, gives us this, where we've got the profile of the bottle, but an extra chunk taken out here to provide clearance for the meshing shaft on the other side. So hopefully that makes sense. And then of course we repeat the operation with the out shaft, with the clearance out shaft, and that takes an extra scoop out here. You can see the colours help to see what the yellow shaft is doing here. It's taking an extra scoop out to provide extra clearance. And then we update the main shaft with our changes. So effectively we're combining this shaft with this shaft, gives us a scooped out in shaft plus a scooped out shaft, all in one composite sort of shaft, if you will. And we can see all the colours merging together and the effects of all the shafts there. And that's the point where we then go back to the assembly. We check the clearance in the assembly. We'll often find actually that we need to make more adjustments to the shape of the cutaway in the clearance shafts, in our sort of scoop clearance shafts, to get a final clearance of these two shafts meshing together. And once we're happy, we open up all the 4 shafts that are creating this sort of composite shaft, and we update them to create a smooth version of each of those. So that can take a little bit of time. And then we update all of the derived parts to show the new smooth geometry, solid bodies. And we finally check it in the assembly, and you can see here we have got a good clearance between all of the shafts. And then the job is done. Let's just confirm that in this final shaft here we do in fact have good clearance. So you can see here, slow this down a little bit more. So it's not simple to get this clearance here between the two shafts as they're moving around, but you see you definitely do need the extra scallop that's taken out from the clearance shaft here or here as the shafts are meshing together. Okay, so this varies depending on the design that you've chosen, but the same principle can be followed typically. Okay, so it's going to take us some time to create these, but I'm going to walk you through step by step so it's easy for you to follow and adjust it to your own design. So I'm going to start this completely from scratch. I'm going to hit new part and hit generate. So we've still got the old settings from previous tutorial, but let's head back to our PowerPoint slideshow and let's check the sizes that we want. So overall diameter of the shaft is 460 millimeters. And my shaft length is 700, which I think we've already got already. Yeah, that's fine. So I'll put 700 in there. That's fine. And my start bottle diameter, or the diameter of the bottle from the center of the shaft is 280. So that's going to be this dimension here, 280 millimeters. And let's see if we head back here. And my end diameter is going to depend on whether we're doing the in shaft or the out shaft. So let's start with the in shaft, and at the end the bottles are 100 mil on diameter, so 50 mil from the center of the shaft. So let's put in 100 here, and you'll see that update. And then we've got the lead in and the lead outs to take care of. So for the bottle distance from the center, let's see if we've got that noted. So the bottles start moving in at 200 mil from the start of the shaft, and they reach the inside diameter at 200 from the end of the shaft. So that's going to be 200 for both of these numbers here, so let's set that to be 200 as well. See the preview updates there as well. And bottle pitch isn't something we've covered yet, so let's head back and look at the bottle pitch. So remember, we're only drawing half of this shaft effectively initially. We're only drawing the bottles that go in. So it's only going to be this one, this one, this one, and this one in this case. So the pitch is actually 135 at the start, not 67.5, because that's the out bottle that's going to be heading outwards. So 135 at the start is the pitch. See the preview update there, and at the end the pitch is going to be 200 at the end here. Okay, and let's just see what other dimensions we need. Okay, so this is where the pitch starts changing. So I don't think we've made any notes of where we want the pitch to start changing here. Okay, well, bottle pitch lead in is going to start changing the bottle pitch at 135 mil from the start, and the bottle pitch has finished changing 400 mil from the end of the start the shaft. So 400 mil from the end of the shaft. So the bottle pitch itself is changing in a very short period of time, actually. 700 minus 400 minus 135, which is not a lot of space for the bottle pitch to change. And we definitely also want to change the bottle shape. So let's hit edit bottle shape here. And we'll go with an elliptical shape, as we had in the previous example. We can sketch any bottle shape here that we want, but let's refer back to our PowerPoint. There's the ellipse size, so 25 and 20 on the radius there. Okay, let's finish the sketch. Accept, generate, yes, yes. Okay, and bottle rotation, we're not actually going to include any bottle rotation in this case. We've covered that in other videos as well. Okay, we're just about ready to start a preview build of this, but if we preview build this, we'll get just holes taken out of the middle of the shaft here. So what we actually need to do is to allow for that in our bottle shape here. So I'm going to, as we don't have any bottle rotation here, I'm going to actually draw a bit of an envelope around the bottle outside, and hit trim and trim the inside here, and hit finish sketch, just so that we get a bit of a better idea of how this is going to appear. Okay, so I've still got the same profile intersecting the shaft here. So I'm now going to hit preview build, and we'll see what this looks like. Okay, this is taking slightly longer to run because of the complexity of the shaft. And then when when this is done, if we're happy with it, we can take a copy of this shaft and build the out bottles, the out bottle route as well. Okay, so there's the bottles moving in towards the center of the shaft. So I'm happy with that route at least, and I'm going to save this. So I'm going to call this splitter in. So the bottles are moving in here. And I'm going to save this part and do a save copy as, and I'm going to call this splitter out. And let's close this one. Let's open up the splitter out. And we want to make a change to this one and make the bottles move outwards. So if we refer back to our PowerPoint, the bottles that are moving outwards want to be 460 millimeters, the same diameter as the shaft effectively. So if we set the end bottle distance from center to be 460, well, we can see the bottles are moving outwards there. We'll leave the same low preview build accuracy and we'll hit go on the preview build. So that's the only thing we've changed here. Although by the looks of it, it looks like we've got a slightly erroneous shaft length there of 703 millimeters, so we might have to check that and set that back to 700. Not sure how that changed. Let's reset that to 700 and run this again. Must have hit the scroll bar by accident, and everything else is correct, I think. So let's hit preview build on this. Okay, so we've now got a preview in and a preview out shaft. So let's hit save on that. And let's head back to our PowerPoint for instructions. So if we head down, we've done step 2 now. We probably want to apply different colors to the solid bodies, but then we're going to derive one part into the other. So let's do our different colors here. So I'll set the color on the splitter out. Let's use the Autodesk Appearance Library. Okay, that's my splitter out. I'll open the splitter in. Set a different color on this solid body. It seems like a lot of effort to do that, but it does benefit you down the line. You can see where all the colors are coming from. Let's save this one. And let's derive the splitter out into this splitter in part. So I'm going to hit derive and type in enough letters to get the splitter out and say open. And I don't want the 3D sketch, I only want the solid body. So I'll say OK to that. And then referring back to our slideshow, we need to use the Move Body tool to rotate the Derive shaft by 180 degrees. So I'm going to go to find Move Bodies here. And let's pick the derived body, which is this one. And let's choose Rotate here. And the axis is the y-axis here, and the angle is 180 degrees. So let's say OK to that. Doesn't matter which direction we move that. And then we combine the two of them together using the Combine tool. And we in fact intersect them using this option. So the base is the first shaft, and the tool body is the second one. And we say OK. And this operation can actually take few seconds to calculate because we've got the rough geometry here. It's actually harder for Inventor to calculate the Boolean operation here for the rough geometry than it is for the smooth geometry later on. But there we go, we've got the intersection of those two shafts there, and that's not looking too bad there. So what we need to do now is save this part first off and assemble it twice into an assembly to start checking the overall interference. So if I right click and copy this part, let's create a new assembly, and let's call this, if I paste this, if I hit Ctrl V to paste this shaft in twice. And now we need to constrain these two shafts relative to each other. So I don't want to ground either one of them because later on I want to drive the constraints. So I've got both of them free to move, and I need to hit constrain and constrain the axis of the first one, so the y-axis of the first shaft with the y-axis of the assembly. Apply that. I need to mate the front face of the shaft with the relevant plane in the assembly, and then that should be free to spin, that shaft there. And then I need to offset this one by the appropriate distance. So I'm going to create a work plane for that and offset this work plane. And what's the distance that I should be offsetting that work plane? Well, if I head back to my PowerPoint, it's going to be this distance. It's going to be the distance at the start, 280. So if I set that to be 280, and then I want to constrain the axis of the second shaft with this plane to this plane. Apply that flush with the front faces of the shafts. Apply that. And then I just want to make sure that it's at the right height here. So I can use a constraint on this plane on the assembly to the axis of the shaft. I'm doing that so that it's still free to rotate there as well. Let's turn off the visibility of that work plane for now as well. Okay, so if we move this around so they're both in roughly the right position, we can see that we've still got quite a lot of work to do in order to get these shafts to be aligned with each other. To get a clearance between these two shafts. So next operation, if we save this assembly, let's call this splitter assembly. We can get our drive constraint in here now. It's not a bad time to do it. So if I put a constraint on here, an angled constraint, let's use this type of angled constraint between, let's say, the YZ plane of that part with the YZ plane of the assembly. And let's call this angle equals, let's make it 180 for the moment. And then let's put a constraint on the second shaft. Let's say constrain, let's use this type of constraint between the YZ plane and the YZ plane. Okay, and if we type in angle here, we can use the first angle constraint and we'll say OK. And now if we try and drive that, so let's just rename this constraint and call it drive me. So let's right click and drive it. Let's change our repetitions, start and end. Let's make it 100 times so we can keep on going with that. Excuse me, let's set our start to be 0 and our end to be 359 degrees. And that looks okay, except for the fact that we need to reverse the direction. So let's just say OK. And this second one needs to be minus angle by the looks of it. And let's try and drive the first one now. Okay, so we're getting the right constraint behavior there if I zoom in. Okay, and now we just need to work on our clearances between the two shafts so they can actually successfully mesh without clashing with each other. So I'm going to say OK to that, and let's save this assembly. And now if we head back to our PowerPoint, let's look where we are. So we've made it this far. We haven't actually done this sculpting away of the outside of the shaft yet, but we're going to save this for later because otherwise we have to redo it. So we're going to come back to that one. We know that we do in fact need extra clearance here, so we need these extra sculpting shafts that are going to scoop out some extra material from both the in and the out shaft. So let's head over to them. So here's the in shaft and here's the out shaft here. So this out one is easy. We're going to take a copy of this and take an extra chunk out of it. So let's say file save as, or file save file save copy as, in fact. So we're going to call this splitter out clearance. And let's close this part. Let's open up that part we just saved. And we'll probably still use a preview build here because it's just so much faster. But what we need to do is we need to hit generate, say yes. And if we edit the bottle shape, we can leave everything else the same, but we now need to generate some clearance around here. So I'm going to leave that as a construction line, this line here. And I want to get rid of these extra lines here. And what we need to do here is, it doesn't have to be exactly like this, but we need some kind of a clearance like this. So it doesn't have to be intersecting the shaft here. It can be, let's just try that for our first example here. Let's make sure this is right in terms of how horizontal it is. Let's horizontally constrain that to there. Okay, let's stick a dimension or two on here. So let's say that could be 55 for the moment. So you'll need a bit of experimentation with this. Let's set this to be, for now, let's set it to be 20. And let's constrain this. I won't bother about constraining that construction line for the moment. And we would probably want to also build the back of it out for the purposes of these preview videos. So I'm going to hit this line tool here and build that out a bit so that I can actually cut away the outside of the shaft as well, for this preview build at least anyway. Okay, and I don't need extra dimensions on that for now. I'm just going to try this for my initial preview build here. So let's finish the sketch. Accept, generate, yes, yes. And there's my potential shape for the clearance that I'm going to generate. So I can leave everything else exactly the same and just hit preview build here. So this is the clearance shaft for the out bottles that we're generating here. And once this one's built, we'll actually be deriving this one into the original out shaft in order to take an extra scallop out of there. Okay, there's the preview shaft. Let's maybe change the color of the solid body so that we can see what we're doing. Make this one white-ish. Let's close that. Let's open the splitter out and let's derive in our clearance part there. So we're going to say manage, derive. This is going to be splitter out clearance that we're deriving in. And we don't need to rotate this one, so we don't want the sketches, we just want the solid body. I'm going to say OK and OK. And we don't need to rotate it because these are going to be in the same position. So we don't need to do a move body, we just need to do combine. The base is this one, and the tool body is this one, and we want to intersect. So we say OK. And this will probably take a little bit of time because of how many blocky bits of geometry we've got on this preview build shaft. Okay, so there's our extra scalloped clearance as the bottles move out. That looks fine. Let's maybe turn off the display of this sketch as well and save this shaft. So now if we go to the splitter in shaft, what we'll see is, it's looking for an update because of course we've changed the splitter out shaft altogether. But what we're going to do is we're just going to drag the end of part up here to get it back to its previous state, and then we're going to do a save as on this part. So I'm going to do file save copy as, and here we're creating the splitter in clearance shaft as well. So I'm going to call this splitter in clearance, and then I'm going to go and open that. So file open, splitter in clearance, open. And we don't want all the stuff after the end of part, so I'm going to right click and delete all features below it, end of part, and I'm going to hit generate. And now's the point where I wish I remembered the clearance size that we'd specified there, but let's give it a shot. So let's hit edit bottle shape, and we are going to delete these extra lines. I'm going to do a similar thing to that which we did on the out clearance part. I'm going to convert that to construction geometry. I'm going to draw an ellipse down here, join that to there for now, specify my size for this. So I think that was 55, wasn't it? And then 15 for that, and then tell it that needs to be vertical, tell it this needs to be on there for now. We still need a dimension or two, so let's fix this. Let's make that horizontal for now, between there and there. Okay, and then we also need the back end of it in this case, because the bottle's not rotating, as we said before. Okay, that's enough for now, so I'm going to finish that sketch. I'm going to hit accept. I'm going to hit generate again, and yes, and yes. And there's the shape ready to build. And I just hit preview build again, so this is going to be our splitter in clearance. So the bottle is going to be going in again. Okay, there we go. So I'm going to change the color of this solid body just for my sanity here. Let's set that to be midnight blue color, and let's save this part. And then we want to go to the splitter in part, and we actually want to derive this in. So I'm going to say manage derive, just like we did with the other part. We're deriving in splitter in clearance in this case. Don't need the sketches, just want the solid body. Say OK. Don't need to move it, we just need to intersect the two of them now. So I'm going to say 3D model, combine, pick my base, my tool body, intersect, OK. Okay, there's my result, and if I sort of rotate this with my 3D mouse, you can see we've got the extra scallop as expected there. Okay, so we may be able to mesh the shafts with this initial clearance, or we may need to tweak that a bit. But let's drag the end of part down, and then we're also deriving in the splitter out, and we'll see the combination of both shafts now, or in fact all 4 shafts, the combination of them. That'll take Inventor a minute or two to figure out as well. There we go. Okay, that's not looking too bad. So let's save this, and then let's head back to the assembly and see what we look like. Okay, so let's drive our constraint. So we've got plenty of clearance over here. You might actually in fact want less clearance here in order to get a good handle on the bottle, although it looks like you're making sure the bottle can't fall out there at least. But we certainly do need a bit more clearance here. This actually looks good in this area. We're getting clearance there as well. So it may just be this area here, and we can probably get a bit less clearance up the top here, but I'll leave that for this video. Obviously you can tweak to get the best result, but if I say OK and cancel on that, all we need to do then to get the clearance here is to do that sculpt operation that I mentioned at the start. So if I open the splitter in shaft, we can do this all in one go, and it's simple enough. All we have to do is to find the bottle center position sketch here. So if I turn this on, what I can actually do is revolve it. So if I hit revolve, I can pick the profile. If I revolve this as a surface, I can pick that profile in the sketch, and the axis can be the y-axis, and I can revolve that. Okay, so I'm revolving the sketch that goes in. I actually want to revolve the sketch that goes out here. So what I would need to do in that case is to go and maybe bring in that sketch out of the splitter out part, if you see what I mean. So let's turn off that sketch here, the bottle center position sketch, and let's go into the splitter out part and edit the derived part. Let's bring in the bottle center position sketch here. Let's say OK. So you see what I mean, we need the sketch that goes outwards here to trim the outside. Let's bring that in. Of course you can just sketch your own shape that you want to trim it to, but in this case it's convenient to use that sketch in here anyway as a starting point. So if I say revolve as a surface, pick my profile, pick the axis as the y-axis of the shaft, and say OK. I've got a surface here that I can use for trimming. I may want to offset that slightly inwards because that's not actually going to give me much of a cut here. So I can do that with the thicken offset tool. So if I use that here, I'm going to say I want to do it as a quilt. I want to offset as a surface. Then I can pick this whole surface and offset. Let's just try offsetting inside by maybe 2 millimeters initially. Let's say OK. So you see I've offset that surface inside here, and now I can use the sculpt tool. So it's a handy way of chopping material away from a part. If I hit sculpt, the surface I want to use for sculpting is this inside surface here, and I want to remove material, so I need to hit this button here, and you'll see a preview of the material that I'm about to remove. So I'm not actually chopping any material away from the outside here, only this narrower section here, and it will be a nice smooth cut. Now if I was to change the colour of that sculpt feature, I'll see what I have in fact chopped away here. Let's let's set that to be equal to the snow colour. You see what I've chopped. Okay, and I will turn off the display of that revolve by right clicking on it and hitting visibility. Okay, so now if I save this part, let's see if that's bought us enough clearance at the start here. Let's drive that constraint. Let's drive it the other way. So that's looking pretty nice there. And we do have enough clearance as the bottles move up, and if we're moving down, we've also got enough clearance here. In fact, it looks to me as if we can loosen up that clearance a bit. We're actually cutting a bit too much material away here. We can afford to keep a bit of this material to make that ellipse a bit narrower. So let's stop this. We won't change that now. I'll just convert this to smooth geometry, and I won't do any more tweaking of it. Okay, so we've reached the final stage really. We need to go into each of those 4 parts that are used to merge and create this combination shaft, and convert the geometry to solid. So this is where it's useful to start several sessions of Inventor. So let's head into here. So I'll start out with the splitter out and the splitter out clearance part. So if I open that base component, so splitter out clearance first, let's hit generate. Yes, I'll use a reasonably low accuracy. If I want to edit the bottle shape, what I really need to do is to get rid of this extra geometry on the side here if I'm going to be drawing this for real. Perhaps I can extend that line using the extend tool. Nope, it appears not. Nope, okay. Let's see if we can draw the ellipse over the top. See if it'll let us do that. Okay, if I finish that sketch and hit generate, there we are, we've got the ellipse for the clearance all ready to go there. We'll use a, as I say, well, we'll use a low accuracy, let's say 800 grid lines or so. It's quite a simple bottle, so we'll have a low number of surfaces, and we can just hit smooth build and ready to go. So this is splitter out clearance. We start generating that. What we'll do is we'll start another session of Inventor, and we'll generate the splitter out that isn't the clearance, that's the actual bottle shape, and we'll have both of those generating at the same time. You can see this one's 8% done already, so that one should generate pretty fast. Okay, and so now we're opening up splitter out. And we're going to drag the end of part up. And we're just going to generate the smooth geometry for that. So we need to edit the bottle shape again. We don't want this geometry on the back here. We could probably get away with not deleting that, but just to be safe, I'm going to get rid of it. Let's finish that sketch. Let's say OK. Let's hit generate again. And there's my bottle shape. and then I choose the accuracy again. So let's do roughly the same as the first shaft, and let's make it lower complexity, and we will hit smooth build here as well. So that's the splitter out and the splitter out clearance that we're taking care of. Okay, so I'm going to pause this video while both of those shafts generate. I won't start a third or fourth session of Inventor, as I've also got the recording software running. I don't want to completely kill my machine. Okay, there's my splitter out generated. Nice smooth geometry. Let's save this one. And if I switch over to the other session of Inventor, then this one's created as well. So this is the clearance shaft. Let's save this one as well. And once these are saved, we'll do the same thing with the solid body color. So let's find this end solid body, find a sensible color for it. Very sensible color, that one. And if I pick the splitter out, the splitter out with the smooth geometry, the splitter out clearance, we're going to close all of these open files because we have two open sessions of Inventor, so we've got to be careful not to overwrite files, and I will overwrite the solid body color here. Let's change to the Autodesk Appearance Library. Let's just change this to Midnight Blue. Save that, and we can drag the end of part down here and rebuild with the derived part of the splitter of the clearance part. But what we'll see is that we get a failure there because we need to point to the new solid body that we just created. So I need to edit derived part, and I need to point it to this new finished scroll that I just created, and say OK. And then the combine operation also, I need to double click on that and point to the new tool body, which is this derived part here. So the base is the finished scroll, and the tool body is the derived, the yellow one in this case, and say OK. And the actual combine operation should be much quicker now because it's smooth geometry. So there we have the smooth version of the out shaft, which I'm going to save. And so I really should have reduced the thickness of that clearance there. I might do that on the in shaft in a minute just to see what that looks like. So we've saved the splitter out shaft. Let's close everything, and now let's open the splitter in, and let's do exactly the same thing. So splitter in, let's open that one up, and the splitter in clearance, let's open that one up as well. Okay, so this one, I'm going to hit generate, and I am actually going to reduce the width of that bottle clearance here just because it was a bit excessive. Let's just take that down to 50. It won't make much difference, but a last little tweak, and let's draw another ellipse over the top of here. Okay, and let's finish the sketch. Accept, generate, yes, yes. And let's set the accuracy to something sensible. And we can reduce the complexity and say smooth build. So this is the splitter in clearance part. Let's just close this and save this before we generate it properly. And let's hit smooth build now. So that's the splitter clearance part. While that's building, let's go, you can see, yeah, that's going away. Let's go open Inventor, another session, do exactly the same as we did before. We'll open the splitter in part, and we will build a smooth version of that as we're building this clearance part. Okay, split it in. I'm going to drag the end of part down here because we don't need those other references to the other parts quite yet. We're just going to rebuild this one. So I'm going to hit generate. We're not making any changes in here except for sorting the bottle shape out to actually reflect the true bottle shape. Let's hit ellipse. Finish sketch. Accept. Generate. Yes, yes. There we go, and this one is ready to go. So you can see Inventor, my computer's already thinking about a lot. This form's not updating, but that's okay. I can adjust the slider and I can just hit smooth build here. And we can see that start going. Okay, I'm going to pause the video while this is going as well. Okay, we've got both of those shafts created successfully. This clearance shaft took about, just under 10 minutes to create with a slightly higher accuracy. That looks good. Let's override the solid body color as usual. Switch to our Autodesk Inventor, Autodesk Appearance Library. Let's choose a color for that. Let's just change that color to something else. Okay, let's save that one and let's head over to the splitter in part, which we've actually saved here. So here's where we've got to be careful not to overwrite it. This is in the in another session of Inventor. So let's close it. Let's close Inventor, the other session over here. Let's head into a single session. Let's save this splitter in part. Let's go open splitter in clearance. Excuse me, let's change the color of the solid body here. This is going to be, we'll set this one to be white. Okay, and we need to give this a kick to remember the saved file here. So just to be sure, I'm going to close Inventor. Now we've saved this one and open another session. We have to be careful not to overwrite files from another Inventor session, especially when we're using derived references. So it's safer to save them and close Inventor and reopen in some cases. Right, so we want splitter in. We also want splitter in clearance. So I'm going to open the splitter in clearance first, I think. Okay, and then splitter in. Okay, so they're both updated. If I now drag the end of part down to rebuild that, I need to point it to the new solid body of the smooth splitter in clearance part that we just built. So I'm going to say edit derived part and point it to the smooth solid body there. Okay, the combine operation needs repointing as well. So if I double click on that, I need to point it to the base body is the finished scroll, the tool body is the derived clearance part. Say OK to that. And we just need to work our way down, rebuilding these features really. We can see here that's got the in part all created successfully. Then we can drag and we'll have to repoint to the splitter out as well. So if I right click and edit derived part here, the reason we have to do all this repointing at the solid bodies is because every time we generate a new shaft, we create a whole new solid body there, so it won't retain a reference to the old solid body. Let's turn off the sketches there. In fact, we might still want to keep our bottle center position sketch. So we'll say OK. We've got a move body applied on that, which also needs repointing to the splitter out part. So the body for that is this one. And still 180 degrees is fine. Okay, and need to drag it down and rebuild this combine operation again. And the base is always the finished scroll, the tool body is the derived part. Let's say OK. And this should be nearly done now. It was just the extra sculpt operation on the end. So remember we had a revolution here of a surface body which we offset and then we sculpted it, didn't we? And we'll have to point that sculpt to the new solid body as well. So if we double click there, it should sort itself out. Yep, and we'll say OK. We might change the color of that solid body so we can see which operation that one's performing as well. So that one's sky blue medium, we can see there the operation that the sculpt is performing. Let's turn off the display of this revolution. You can see a nice patriotic shaft that we've created here. So let's save this. And if we now head back to our top level assembly, once this is finished saving, we'll be able to check that our clearances are still good, even though I reduced the width slightly. And when we go back to the top level assembly, of course, we've done some mates and flushes on the old solid bodies. So we're going to have to double click on these and, we're going to have to right click on these and edit and point these to the solid bodies that are the new solid bodies. In fact, it's probably easier to delete them, see what can still move. Okay, so we need a constraint on that part. So let's hit constraint, mate that face to this face in the assembly and apply. That's fine. What can still move, that needs to be mated as well. So I can do a constraint, flush those two and hit apply. And we want to be able to rotate using the same drive constraint that we had before. If we check the clearances here, see actually we might have messed it up slightly by reducing that clearance, but actually no, the shafts are out of alignment at the moment. So let's drive that constraint and let's see. Okay, so let's go into this angle down here, and it looks like that now needs to be not a negative of the first shaft angle. Let's try driving that constraint again. Okay, that looks a bit better. Looks like we've still got clearance here, although it's only a very slight clearance, so we might want to increase the size of that scallop, but we definitely have clearance depending on how accurate our shafts are. And it looks like poetry to me. Very nice. Okay, well, thanks very much for watching, and I hope this inspires you and gives you the capability to take your business forward to create new feeds or scrolls that you weren't previously capable of creating. And keep the good ideas coming. Thanks a lot for watching.